Hello students, welcome to the course on chemistry. In that we are discussing about hydrocarbons. In hydrocarbons we have studied classification of hydrocarbons and how to prepare the alkanes. There are three methods. By using those three methods we can prepare the alkanes that we have studied. Now in this video I am going to explain about the properties of alkanes. So what are the physical and chemical properties of alkanes that we will study? First, let's see the physical properties of alkanes. So alkanes are almost non-polar molecules. Non-polar molecules means what? The covalent bond is formed between the atoms having same electronegativity. ಸೊ ಇಲ್ಲಿ ನಾನ್ ಪೋಲಾರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ ಅಲ್ಲಿ ಯಾವುದೇ ಒಂದು ಮಾಲಿಕ್ಯೂಲ್ ತಗೊಂಡಾಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಐ ಟೇಕ್ CH4. ಸೊ ಇನ್ ಕೇಸ್ ಆಫ್ CH4 there will be no charge present on the atoms. So if I take hydrogen, the net charge on hydrogen will be 0. Means that molecule is electrically neutral. Such type of molecules are said to be non-polar molecules. If I take water, if suppose water ತಗೊಂಡೆ ಅಂತ ಹೇಳಿದ್ರೆ the bond in water, the HOH bond is present, and in O delta minus charge is there, and on H delta plus charge will be present. So therefore such kind of molecules are said to be polar molecules. So if they have any partial charges on them, then they are said to be polar molecules. If they does not have any partial charge on atom, then they are said to be non-polar molecules. And in case of alkanes, the carbon and hydrogen, they are almost having same electronegativities. Thus they are considered to be non-polar molecules. ಇಲ್ಲಿ ಕಾರ್ಬನ್ ಮತ್ತು ಹೈಡ್ರೋಜನ್ ನಡುವೆ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಆಲ್ಮೋಸ್ಟ್ ಸಿಮಿಲರ್ ಇರೋದ್ರಿಂದ ಅಲ್ಲಿ ಯಾವುದೇ ಚಾರ್ಜ್ ಡೆವಲಪ್ ಆಗಿರುವುದಿಲ್ಲ, and thus we say them as non-polar molecules. Second property is they possess weak van der Waals forces. So since they are non-polar molecules, they possess weak van der Waals forces. It may be London force, dipole-dipole force, dipole-induced dipole force, or hydrogen bond. So weak van der Waals forces present irtav non-polar molecules ನಡುವೆ. And in case of alkanes, due to these weak forces, first four members, that is from C1 to C4. C1 to C4 means the molecule containing one carbon to the molecule containing 4 carbon atoms. Means ಈಗ ಮೀಥೇನ್ ತಗೊಂಡ್ವಿ ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ ನಂಬರ್ ಆಫ್ ಕಾರ್ಬನ್ ಅಟಮ್ಸ್ ಎಷ್ಟಿರ್ತಾವ್ರಿ? 1 ಇರುತ್ತೆ. ಆ್ಯಂಡ್ ಸಿಮಿಲರ್ಲಿ ಈಥೇನ್ ತಗೊಂಡ್ರೆ ನಂಬರ್ ಆಫ್ ಕಾರ್ಬನ್ ಅಟಮ್ಸ್ 2 ಇರ್ತಾವೆ. ಪ್ರೋಪೇನ್ ತಗೊಂಡ್ರೆ 3 ಇರ್ತಾವೆ. ಬ್ಯೂಟೇನ್ ತಗೊಂಡ್ರೆ 4 ಇರ್ತಾವೆ. ಸೊ C1 to C4 molecules are present in gaseous form. So methane, ethane, propane, butane, due to the weak forces, they are present in gaseous form. And from C5 to C17, they are present in liquids. So why they are present in liquids? ಯಾಕೆ liquids ಒಳಗೆ present ಇರ್ತಾವೆ? In case of C5 to C17, as the molecular weight increases, weak van der Waals forces, they also become stronger. Means attractive force will go on increases, or magnitude of van der Waals forces go on increases with increase in molecular size or molecular weight. So that's why from C5 to C17 they are present in liquid state, and the molecules which are containing 18 carbon atoms, they are present in solid state. Okay, So due to the presence of van der Waals forces, we will see the different states of alkanes depending upon the number of carbon atoms present in each molecule. So this is the another property, and they are colorless and odorless. Okay, so colorless means ಯಾವುದೇ ಬಣ್ಣ ಇರುವುದಿಲ್ಲ ಮತ್ತು odorless ಅಂತ ಹೇಳಿದ್ರೆ they don't have any smell, ಯಾವುದೇ ವಾಸನೆ ಇರುವುದಿಲ್ಲ. And these are soluble in non-polar solvents. Since they are non-polar molecules, the non-polar solutes will dissolve in non-polar solvents and polar solutes will dissolve in polar solvents. That is the property which is usually said to be like dissolves like property. Like dissolves like property ಅಂತ ಹೇಳಿದ್ರೆ polar molecules ಅಥವಾ polar solutes polar solvents ಒಳಗೆ dissolve ಆಗ್ತಾವ್ರಿ. Non-polar solutes non-polar solvents ಒಳಗೆ dissolve ಆಗ್ತಾವು. So here alkanes are non-polar molecules and thus they are soluble in non-polar solvents. The boiling point increases with increase in molecular mass. So as we know, with increase in molecular mass, the attractive forces gets increases. Due to the increase in attractive force, the boiling point will also increases. The boiling point ಏನಾಗತ್ರಿ, molecular mass ಹೆಚ್ಚಾದಂಗ ಅದು ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ನು ಹೆಚ್ಚಾಗ್ತಾ ಹೋಗುತ್ತೆ. ಯಾಕೆ ಹೆಚ್ಚಾಗುತ್ತೆ? ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಜಾಸ್ತಿ ಆಗ್ತಾವೆ. ಡ್ಯೂ ಟು ದಿ increase in magnitude of van der Waals forces, the boiling point gets increases. And in case of isomers, isomers having linear chain are having high boiling point than isomers having branched chain isomers. So ಇಲ್ಲಿ ಏನರ್ಥ? If we take pentane, in case of pentane, we will observe 3 isomers. One is N-pentane and another one is isopentane and another one is neopentane. So among these 3, all are having 5 carbon atoms only. So then which one is having high boiling point? So among these 3, the one which consists of linear chain will have high boiling point. Okay, so ಇಲ್ಲಿ ಸ್ಟ್ರೇಟ್ ಚೈನ್ ಅಥವಾ ಲೀನಿಯರ್ ಚೈನ್ ಯಾವುದಿರುತ್ತಲ್ಲ ಅದರದ್ದು ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಯಾಕೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ? ಬಿಕಾಸ್ ದಿ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸಸ್ ಆರ್ ಸ್ಟ್ರಾಂಗ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಲೀನಿಯರ್ ಚೈನ್, and thus in case of normal pentane, since it is having linear chain, it has high boiling point, okay, than iso and neopentane. Remember this, isomers having linear chain are having high boiling point than isomers having branched chain isomers. So these are certain physical properties of alkanes. Now we will move to the chemical properties of alkanes. Alkanes usually they are inert in nature. Inert means they won't react with any other reagents. Okay, ಬೇರೆ ಯಾವುದೇ reagents ಜೋಡಿ react ಆಗುವುದಿಲ್ಲ at normal conditions. But in case of certain catalyst or by applying certain heat or light, we can carry out the reactions in case of alkanes. And so we will see which kind of reactions will be shown by alkanes. So first one is substitution reactions. So substitution reactions means what? The reactions in which hydrogen atoms of alkanes are substituted are known as substitution reactions. So ಇಲ್ಲಿ substitution reaction ನಲ್ಲಿ hydrogen atoms ಏನಾಗ್ತಾವ್ರಿ, replace ಆಗ್ತಾವ್, and in place of hydrogen another atom will comes and forms the bond with carbon. In such case we will say the reaction is substitution reaction. So here I have taken the one example, that is chlorination of methane. So chlorination of methane, it is an example of halogenation. So halogenation means here in place of a hydrogen atom, we will substitute the halogen atom. Halogens means they may be chlorine, bromine, iodine, fluorine. So first see this. In case of CH4, I have reacted chlorine gas in presence of the light, and thus it will form CH3Cl. So what happens actually here? So simply I will write the complete structure of methane, CH4. Okay, and now I will react that with chlorine gas. Two Cl atoms are there. Now one of the hydrogen gets replaced by Cl. Since Cl is more electronegative, when we pass the ultraviolet rays or sunlight, then it will replaces the hydrogen and comes in that position, and thus we will get H, C, H, H, Cl. ಇಲ್ಲಿ H ಅನ್ನು Cl ರೀಪ್ಲೇಸ್ ಮಾಡುತ್ತೆ. ಓಕೆ, ರೀಪ್ಲೇಸ್ ಮಾಡಿದ ಮೇಲೆ H ರಿಮೂವ್ ಆಯಿತು. ಓಕೆ, ಆ್ಯಂಡ್ Cl ಕಮ್ಸ್ ಇನ್ ದ್ಯಾಟ್ H ಪೊಸಿಷನ್. ನಾವು ಅನದರ್ Cl ಇಸ್ ದ್ಯಾಟ್, ಇನ್ನೊಂದು Cl ಉಳಿದಿರುತ್ತೆ. ಆ ಇನ್ನೊಂದು Cl ಎದ್ರ ಜೋಡಿ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ ರೀ? H ಜೋಡಿ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ ಆ್ಯಂಡ್ ಫಾರ್ಮ್ಸ್ HCl. ಸೊ ದಸ್ we will obtain CH3Cl and HCl as a byproduct. So that CH3Cl is said to be chloromethane. And if we further continue this reaction, ಈ ರಿಯಾಕ್ಷನ್ನ ಕಂಟಿನ್ಯೂ ಮಾಡಿದ್ವಿ ಅಂತ ಹೇಳಿದ್ರೆ ಮತ್ತೇನಾಗುತ್ತೆ ರೀ? ಕ್ಲೋರೋಮೀಥೇನ್ ಅಗೇನ್ ಇಟ್ ವಿಲ್ ರಿಯಾಕ್ಟ್ ವಿತ್ ಕ್ಲೋರಿನ್ ಗ್ಯಾಸ್ ಆ್ಯಂಡ್ ಅಗೇನ್ ಸೇಮ್ ಥಿಂಗ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್. ಮತ್ತು ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ರೀ? ಇಲ್ಲಿ ಇರುವಂಥ ಮತ್ತೊಂದು ಹೈಡ್ರೋಜನ್ನ Cl ಅಟಮ್ ರೀಪ್ಲೇಸ್ ಮಾಡುತ್ತೆ. ರೀಪ್ಲೇಸ್ ಮಾಡಿ ಅಲ್ಲಿ ಟಾಪ್ ಪೊಸಿಷನ್ನ ಅಕ್ಯುಪೈ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. ಆ್ಯಂಡ್ ಆಸ್ ಎ ರಿಸಲ್ಟ್ ಆಫ್ ದ್ಯಾಟ್ ಅಗೇನ್ ವಿ ವಿಲ್ ಗೆಟ್ CH2Cl2 and HCl as a byproduct. Again CH2Cl2. Okay, so if we can see this CH2Cl2, ಎರಡು Cl atoms ಇರ್ತಾವೆ. Again if we react that with chlorine gas, ಮತ್ತೆ ಕ್ಲೋರಿನ್ ಗ್ಯಾಸ್ ಜೋಡಿ ರಿಯಾಕ್ಟ್ ಮಾಡಿದ್ವಿ ಅಂತ ಹೇಳಿದ್ರೆ ಅವಾಗ again one chlorine atom will replaces hydrogen and thus it will form what will remain? ಈ ಹೈಡ್ರೋಜನ್ ರಿಮೂವ್ ಮಾಡಿ Cl ಬರಿಬೇಕು. ಅವಾಗ ಏನಾಗುತ್ತೆ ರೀ? CHCl3 plus this H and this Cl will react to form HCl again. So CHCl3, that is a trichloromethane or commonly known as chloroform. Okay, remember the formula of chloroform, that is CHCl3. Okay, that is obtained, or we can also call it as trichloromethane. Again, if we further react the chlorine gas with chloroform, then again it will remove one of the hydrogen and it will form CCl4, and it is said to be tetrachloromethane, or it is also known as carbon tetrachloride. Commonly it is said to be carbon tetrachloride. So this is how the substitution reaction will takes place, and here the chlorine is substituted and it is said to be chlorination of methane. So in generally, if the substitution of halogen atom takes place, then that reaction is said to be halogenation. So one or more hydrogen atoms, they gets replaced by some other atoms, and such kind of reactions are said to be substitution reactions. Okay, so remember this example. And here, since we have taken chlorine here, and this can be applied to other halogens also, like chlorine, bromine, iodine, fluorine, and how the rate of reaction varies with alkanes, with halogens. So instead of chlorine, if I take fluorine, which one will be faster? The rate of reactions ant helidrenu, the speed of reaction. So let's take an example. I have taken methane, okay, and I will react that with chlorine gas. What it will form? CH3Cl plus HCl. This is the reaction. Now again I will take methane, but this time I will react that with fluorine. What it will form? CH3F plus HCl. Sorry, HF. So both are halogenation or substitution reactions. Among these two, which one will takes place at faster rate? ಯಾವ ರಿಯಾಕ್ಷನ್ ಬಹಳ ಫಾಸ್ಟ್ ಆಗಿ ನಡೀತದಿಲ್ಲ? In this case, the fluorination of methane is faster and chlorination of methane is slower comparatively. When we compare with chlorination and fluorination, fluorination will takes place faster and chlorination will takes place slower rate. So that is observed from this the order which is given here. Fluorine is greater than chlorine, is greater than bromine, is greater than iodine. ಅಂದ್ರೆ ಫ್ಲೋರಿನ್ ಭಾಳ ಫಾಸ್ಟಾಗಿ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ, ಕ್ಲೋರಿನ್ ಕಡಿಮೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ, ಬ್ರೋಮಿನ್ ಇನ್ನೂ ಸ್ಲೋ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ, iodine still reacts slowly with alkanes. Okay, and again the rate of replacement of hydrogens of alkanes is. So again ille suppose if we take primary, secondary, tertiary alkanes. Primary, secondary, tertiary alkanes means, primary means if the carbon atom is attached to only one other carbon atom, then it is said to be primary carbon, and such kind of alkane is said to be primary alkanes. Okay, and remaining are hydrogen atoms. And if the carbon atom is attached to two carbon atoms, then it is said to be secondary carbon atom. If it is attached to three carbon atoms, then it is said to be tertiary alkanes. Okay, because it consists of tertiary carbon atom and they are said to be tertiary alkanes. Okay, now the rate of replacement of hydrogens of alkanes is tertiary is greater than secondary, secondary is greater than primary. ಅಂದ್ರೆ ಟೆರ್ಷರಿ, ಸೆಕೆಂಡರಿ, ಪ್ರೈಮರಿ ಒಳಗೆ ಯಾವುದು ಫಾಸ್ಟ್ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತಾ? ಟೆರ್ಷರಿ ವಿಲ್ ರಿಯಾಕ್ಟ್ ಫಾಸ್ಟರ್ and primary will react slower. Okay, so in this manner the substitution reaction will takes place. Now we will study the mechanism of chlorination of methane. The mechanism, it is usually said to be free radical mechanism. Free radical means here we will get the atoms which consist of odd number of electrons, and such kind of species are said to be radicals, free radicals. Okay, that you have already learnt. Free radicals means the species containing odd number of electrons or unpaired electron. ಯಾವುದೇ ಒಂದು ಅಟಮ್ ಮೇಲೆ ಅನ್ಪೇರ್ಡ್ ಅಥವಾ ಸಿಂಗಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇತ್ತು ಅಥವಾ ಆಡ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ದು ಅಂತ ಹೇಳಿದ್ರೆ ಅವಾಗ ನಾವು ಅದಕ್ಕೆ ಫ್ರೀ ರ್ಯಾಡಿಕಲ್ ಅಂತ ಹೇಳ್ತೀವಿ. ನೌ ದಿಸ್ ಮೆಕ್ಯಾನಿಸಮ್ ಈಸ್ ಸೆಡ್ ಟು ಬಿ ಫ್ರೀ ರ್ಯಾಡಿಕಲ್ ಮೆಕ್ಯಾನಿಸಮ್ because it involves the formation of free radicals, and it mainly consists of three steps. One is initiation, another one is propagation, third one is termination. So first we will see how the reaction gets initiates. That is said to be initiation. Initiation ಅಂತ ಹೇಳಿದ್ರೆ start ಆಗೋದು reaction. How this initiates? The reaction is initiated by homolysis of chlorine molecule in the presence of light or heat. The chlorine-chlorine bond is weaker than CC and CH bond, and hence it is easiest to break. So ille homolysis process naditadre. Homolysis means what? The cleavage or breaking of bond takes place and the shared electrons are equally distributed to each atom. And thus if we observe this chlorine molecule, here the bond is formed by sharing of electrons, and each bond consists of 2 electrons. ಪ್ರತಿಯೊಂದು ಬಾಂಡ್ ನಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರ್ತಾವ್ರಿ? 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರ್ತಾವೆ. ಈಗ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಯಿತು ಅಂತ ಹೇಳಿದ್ರು, ಹೋಮೋಲೈಸಿಸ್ ಆರ್ ಹೋಮೋಲೈಟಿಕ್ ಕ್ಲೀವೇಜ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಅವಾಗ ಶೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಒಳಗೆ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಒಂದು ಕ್ಲೋರಿನ್ ಅಟಮಿಗೆ ಹೋಗುತ್ತೆ, ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇನ್ನೊಂದು ಕ್ಲೋರಿನ್ ಅಟಮ್ ಹೋಗುತ್ತೆ. ಸೊ ದಸ್ ಈಚ್ ಕ್ಲೋರಿನ್ ಅಟಮ್ ವಿಲ್ ಗೆಟ್ ಒನ್ ಎಲೆಕ್ಟ್ರಾನ್ and thus we say them as chlorine free radicals, and it is carried out by passing light or heat. Here the Cl-Cl bond is weaker than carbon-carbon and carbon-hydrogen bond. Hence it will easily breaks in presence of light or heat. So this is how the initiation will takes place. Now second step is propagation. So now chlorine free radicals are formed. That chlorine free radical which is formed gets attached to the methane molecule. ಏನು ಕ್ಲೋರಿನ್ ರೆಡಿಕಲ್ ಫಾರ್ಮ್ ಆಗಿರುತ್ತಲ್ರಿ, ಇಟ್ ಈಸ್ ಅನ್ಸ್ಟೇಬಲ್ ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ರಿಯಾಕ್ಟಿವ್ ಆ್ಯಂಡ್ ಇಟ್ ವಿಲ್ ಅಟ್ಯಾಕ್ಸ್ ಟು ದಿ ಮೀಥೇನ್ ಮಾಲಿಕ್ಯೂಲ್, ಆ್ಯಂಡ್ ದಸ್ ದಿ Cl, it will takes one of the hydrogen from CH4 forming HCl. If one hydrogen atom is removed from the methane, then we will get CH3 dot, that is methyl free radical. CH3 is methyl and it consists of odd number of electron, and hence it is said to be methyl free radical. So now what happens? This methyl free radical again it will react with chlorine atoms, that is Cl2 gas. So now what happens? This CH3 which consists of odd number of electron, it will attach to this Cl and forms CH3Cl. Now it will takes one Cl, the another Cl will remain as it is, and thus it will get the odd number of electron or unpaired electron on it, and it is again forms chlorine free radical. So this process continuously takes place. Again this Cl atom, it will attach to the another methane, and thus that methane will again form methyl free radical, and that methyl free radical again attacks to the Cl2 and takes one Cl, again that will form chlorine free radical. So this is said to be propagation step. Now you can observe here CH3Cl is formed, and again this Cl dot chlorine free radical which is formed, chlorine radical form ಆಗಿತ್ತು ಅಲ್ಲಿ. ಆ chlorine radical ಮತ್ತೆ ಏನು ಮಾಡುತ್ತೆ, it will take the one hydrogen atom from this CH3Cl, and thus it will form CH2Cl dot, and again it will form HCl. Again that radical CH2Cl, it consists of odd number of electron, it will react with Cl to form CH2Cl2. Again at the end you will get one chlorine free radical. Okay, so this is how the propagation takes place. Then third step, termination. How it ends, ಯಾವ ರೀತಿ ಎಂಡ್ ಆಗುತ್ತೆ reaction? The reaction stops after some time due to consumption of reactants or due to the following side reaction. ಅಲ್ಲಿ ರಿಯಾಕ್ಟಂಟ್ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಕನ್ಸ್ಯೂಮ್ ಆಯ್ತು ಅಥವಾ ಸೈಡ್ ರಿಯಾಕ್ಷನ್ ಆದು ಅಂತ ಹೇಳಿದ್ರೆ ಟರ್ಮಿನೇಟ್ ಆಗುತ್ತೆ ರೀ ರಿಯಾಕ್ಷನ್. ಯಾವ ರೀತಿ? ಇಫ್ 2Cl ರೆಡಿಕಲ್ಸ್ ಆರ್ ಫಾರ್ಮ್, ಎರಡು ಕ್ಲೋರಿನ್ ರೆಡಿಕಲ್ಸ್ ಫಾರ್ಮ್ ಆಗಿದ್ದು ಅಂತ ಹೇಳಿದ್ರೆ, then they will again share the electrons with each other and forms chlorine gas. And if two methyl radicals are formed, CH3 dot, then they will share the electron and forms ethane. And if one CH3 radical and one Cl radical is formed, then it will form CH3Cl, that is methyl chloride, and thus no free radical is present at the end, and thus the reaction will terminates or reaction will stops. If free radical is present, then only the reaction will go on, takes place. But if no free radical is there, then the reaction will get terminated. So this is how the chlorination of methane will takes place. So it is taken place by free radical mechanism, which mainly consists of three steps: chain initiation, chain propagation, and chain termination. Remember this. Now next we will go to the another kind of reaction, that is combustion reaction. This combustion reaction is usually takes place on heating in presence of air or dioxygen. So combustion is nothing but burning. Alkanes are burned or heated in presence of air or dioxygen. And when it is heated, it will react to form carbon dioxide and releases large amount of heat. ಯಾವಾಗ ಯಾವುದೇ ಒಂದು ಅಲ್ಕೇನ್ ಕಂಬಷನ್ ಮೀನ್ಸ್ ಬರ್ನ್ ಆಯಿತು ಅಂತ ಹೇಳಿದ್ರೆ ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಏರ್ ಆರ್ ಆಕ್ಸಿಜನ್, then it will releases carbon dioxide and water along with heat energy. So here one of the example is given, that is methane. When reacts with oxygen, it will form carbon dioxide and water vapors along with release of heat energy. So this is the another reaction that is observed in case of alkanes. Then third type of reaction, controlled oxidation. So if more oxygen is supplied, then it will undergo combustion. And suppose the regulated supply of dioxygen takes place, then the product formed will be different. Variety of products are formed and it is said to be controlled oxidation. So oxygen is supplied, okay, in regular manner or in particular amounts to get desired product. ನಮಗೆ ಯಾವುದು ಪ್ರಾಡಕ್ಟ್ ಬೇಕಾಗಿರುತ್ತಲ್ಲ ಆ ಪ್ರಾಡಕ್ಟ್ ಮೇಲೆ ನಾವು ಎಷ್ಟು ಆಕ್ಸಿಜನ್ ಸಪ್ಲೈ ಮಾಡಬೇಕನ್ನೋದು ಡಿಸೈಡ್ ಮಾಡಬೇಕು. ಸೊ ನಾವೇ ಅಲ್ಲೇ ಆಕ್ಸಿಜನ್ ಸಪ್ಲೈನ ರೆಗ್ಯುಲೇಟ್ ಮಾಡಬೇಕು. ಆವಾಗ ನಮಗೆ ಬೇರೆ ಬೇರೆ ಪ್ರಾಡಕ್ಟ್ಸ್ ಸಿಗ್ತಾವು. ಅದಕ್ಕೆ ನಾವು ಕಂಟ್ರೋಲ್ಡ್ ಆಕ್ಸಿಡೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಅಲ್ಕೇನ್ಸ್ ಆನ್ ಹೀಟಿಂಗ್ ವಿತ್ ರೆಗ್ಯುಲೇಟೆಡ್ ಸಪ್ಲೈ ಆಫ್ dioxygen or air at high pressure and in presence of suitable catalyst give a variety of oxidation products. So regulated supply of dioxygen are 3 ಮತ್ತು catalyst we will use. So catalyst you already know, it is the substance which initiates the reaction or which increases the rate of reaction. Now let's see the example. CH4 reacts with oxygen in presence of copper as a catalyst to form methanol CH3OH. And in second example, methane is reacted with again oxygen in presence of molybdenum oxide to form methanol. And ethane, it will react with oxygen, 3 moles of oxygen to form CH3COOH, that is acetic acid. So in all the cases oxygen is there, but the product formed will be different. So this is observed in case of controlled oxidation. Next, fourth kind of reaction that is observed in alkanes is isomerization. So what happens in isomerization? Alkanes on heating in presence of anhydrous aluminum chloride and hydrogen chloride gas isomerize to branched chain alkanes. So ಇಲ್ಲಿ straight chain ಇದ್ದಿದ್ದು branched chain formation ಆಗುತ್ತೆ. Here I have taken N-hexane. Hexane means it consists of 6 carbon atoms. Now when it is treated with anhydrous aluminum chloride and HCl, hydrogen chloride gas, it becomes branched. ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ರೀ, ಬ್ರಾಂಚ್ಡ್ ಹೆಕ್ಸೇನ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಅವಾಗ ನಾವು ಅದಕ್ಕೆ ಏನಂತ ಹೇಳ್ತೀವಿ, 2-methyl pentane, 3-methyl pentane, because the long chain consists of 5 carbon atoms. Thus it becomes 3-methyl. At third position methyl group is there, so 3-methyl pentane, and here at second position methyl group is there, thus it is said to be 2-methyl pentane. So such kind of isomerization will be observed in alkanes. Then fifth kind of reaction is aromatization. So when alkanes having 6 or more carbon atoms. On heating, in presence of certain catalyst, they will cyclize to form benzene. Means here alkanes gets converted into aromatic compounds. ಇಲ್ಲಿ alkanes ಇದ್ದಿದ್ದು aromatic compounds ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತಾವ್ರಿ. ಅದಕ್ಕೆ ನಾವು aromatization ಅಂತ ಹೇಳ್ತೀವಿ. Now in this case you can observe here I have taken 6 membered alkane. Carbon 1, 2, 3, 4, 5, 6. 6 carbon atoms are there. And in presence of a catalyst, it will get branched. Okay. And it will form a closed chain or ring chain. And it is said to be aromatic compound, which is usually said to be benzene. The benzene is formed when you take 6 membered chain. Okay. So this kind of reactions are said to be aromatization reactions. And this reaction is also known as reforming. Okay. So aromatization or reforming reaction. So these are some chemical properties of alkanes.